Right, example 6. Water lifts a horse at a rate of 1.5 kilogram per second with a speed of 20 meter per second and is aiming at the side of the car, which stops it. Okay, so what is the force exerted by the water on the car? So how do we do that? We know that initially when the water is leaving this when the water is leaving the horse here, we know there will always be a momentum. So let's define that as the initial momentum. So mv, okay, v initial lah. And then when it reaches the side of this car, we know that the velocity of the water would equal to 0, right? So theoretically we have a final momentum that's equal to 0. Okay, so remember momentum ni, it must be moving. Okay, so when the water hit the side of the car, velocity there will be equal to 0. Okay, dia ada tulis juga di dalam question, dia cakap when it hits the side of the car, the car stops the flowing of the water. Okay, so that's why I mentioned at the final momentum would equal to 0. Okay, now why do I care about the initial and final momentum is because we will be using this formula again. Okay, but however the question didn't give us the rate of time, but the question has already give us the rate of how per kilogram per second berapa banyak water yang leaves the horse. So we can assume delta t to be equal to 1 second. So every 1 second there would be a 1.5 kilogram of water leaving the horse. Okay, boleh? Lepas tu kita ada sudah speed. Okay, so now we can write delta p to be equal to mv initial minus delta p is momentum final minus momentum initial, delta t, so momentum final is equal to mvf minus mv initial over delta t. So then substitute m as 1.5, but final we know it is equal to 0. Let's just put 0 and then 1.5. The final the initial velocity is 20 divided by 1 second. Okay, boleh faham yang ini? Since dia bagi water leaves a horse at the rate of 1.5 kg per second, let's just assume every 1 second ada 1.5 kg of water leaves the horse untuk cuci this car. Okay, so that's why I use delta t as 1 and then mass is 1.5. So you'll then get the force being exerted by the water on the car to be negative 30 Newton. Okay, boleh? That is our example number 6.